Greetings, everybody. Welcome to mole conversions. We are going to convert from, well, moles to atoms, and then from atoms to moles. In both cases, we're going to use something that is like an extremely large dozen. It's Avogadro's number, which is 6.022 times 10 to the 23rd. And that's how many atoms are in one mole. Kind of like you've learned in the past, there are 12 eggs in a dozen. This is just an extremely large dozen. So remember the analogy. If you have 3 dozen eggs, how many eggs is that? That's 36, or 3 dozen. If we have 365 moles of helium, so now let's take a look at what we have here. We have a number that's given to us, that's 365 moles. And then we have a quantity that we're looking for. And in this case, we're looking for atoms. So it's always helpful to realize what we're looking for and what we want to and what we want to convert to. So we put what's given, the 365, and we put it over 1. So we take 365 moles, and we put that over 1. And now we use our bottom equality, and we're looking for atoms, so atoms goes on top, 6.022 times 10 to the 23rd atoms. And that's all over 1 mole. Now we're going to find that moles cancel, and we're going to get an answer that's in atoms. And if you press the buttons on your calculator, you will get 2.198 times 10 to the 26th. And then we look at the 365, and we find, well, we've only got 3 sig figs, so we get 2.20 times 10 to the 26th atoms. So in this case, we went from moles and we converted to atoms, and we used the equality on the bottom. In the second instance, we're going to start with atoms, but let's take a look at what we have, which happens to be atoms, and what we want to convert to, which is moles. So now this is the opposite scenario, but notice my similarity in my approach. I'm looking at what I'm given. I'm going to put that over 1, and then I'm going to put what I'm looking for in the numerator of my equality. And so I'm going to say 1.2 times 10 to the 12th atoms, and I'll put that over 1. And then I'll multiply that by 1 mole over Avogadro's number, which is 6.022 times 10 to the 23rd atoms. And in this case, atoms will now cancel, and I'll be left with moles. And if I press the right buttons on my calculator here, I'll end up with 1.9927 times 10 to the negative 12th moles. And again, sig figs are important. We have 2 sig figs, so the answer is 2.0 times 10 to the negative 12th moles. 2 separate answers going from moles to atoms and atoms to moles. Hope you enjoyed it.